Good morning, everybody, or good evening, wherever you are. Welcome to Kasyanno, EZMath. And we have here numbers represented on the board. What are these numbers? Negative 100, negative 2, 0, 5, 1 half, square root of 5, and so on and so forth. We encounter these numbers in our daily lives, and yet we don't give them second thoughts. What these are? What we know is that these are simply different numbers, or we simply say some are fractions, like 1 half, and some are square roots, square root of 5, and decimals right here. And there's another decimal right here. What does it mean by those? Point right on top of those numbers. And you see pi symbol. And this one right here, 2.131131113, and all that. So in mathematics, these numbers are classified under number systems. So that is our topic today, number system. And number systems is split into two parts or two kinds. And there are actually some more than the two parts right here, or two kinds. They are octal, hexadecimal, binary, and decimal number systems. And decimal number system is what we use normally. So in this topic though, we'll be discussing all about real numbers. And number systems in here just classified in just two kinds, but actually there are a lot more than that. So as a basic knowledge in algebra or math, every student in math or algebra should know this. And it's the number system categorized in here, which we commonly encounter in our math or algebra subject. We have here real numbers represented in R, and complex numbers. Real numbers are all numbers that we see in everyday life. We see it anywhere we go. Whenever we deal with the computations of math or algebra problem solving, we see those numbers. And we seldom see these complex numbers. Complex number is somewhat not used very frequently in our daily lives. Complex numbers, we deal with those complex numbers in higher algebra and all other higher mathematics. And in here, I give you a little background of what complex numbers are. Complex number is a combination of the real number and imaginary numbers. It says here R plus imaginary. Real numbers are 3, counting numbers and all that, integers. And imaginary number consists of the imaginary number I, represented by I, and some coefficient like this 2i. That's an imaginary. If we combine these two, it is called complex numbers. Combination of real numbers and imaginary. So that's, and the value of I, the imaginary number I, is square root of -1. And if we explain or we dig into a little bit of the meaning of this, or how it plays in simplifying equations or algebraic expressions, I is whenever you encounter like this negative square root of something, like say negative 3, and negative 3 is equivalent to -1 times 3. So that is -1 times 3. And in here, -1 is the I. So that is actually square root of -1 times square root of 3. Where right here, square root of -1 is I. That's I. So that is equal to I square root of 3. That's how we deal with it in mathematics. That's all for that. Now, main topic is on the number systems. We deal with real numbers. So in here, we all talk about real numbers. So real numbers represented by capital letter R are categorized in two kinds, where you see you had two arrows going downwards. Irrational, or what we say, irrational, and the other part of a real number is all this going down here. So real numbers, you have two kinds, irrational, and the other kinds are rational. And if you notice, under rational numbers, these are all these here, integer, whole numbers, natural numbers. So these fall on one side of real number. So that means all of these category of numbers or kinds of numbers are not irrational. If you notice, these are all arranged in somewhat way, a systematic way, how these kinds of numbers are arranged this way. So that means this is natural number is a kind of whole number, and a whole number and natural number are integers, and integers, whole numbers, natural numbers are rational numbers, but not irrational numbers. So these are all kinds of numbers is the opposite of these irrational numbers. Okay, so to gain more knowledge about that, let's do this. So for you guys to get a clear understanding of what we're talking about, the real numbers, we try to enlighten everyone by representing all these kinds of numbers on a number line. If you take a look at this number line, here's the number line right here with arrows on both ends. That means it goes on and on to infinity, from to the right and to the left. If you see these numbers 1, 2, 3, 4, 5, what do you call these numbers over here? So these are natural numbers. So these are natural numbers, or what we call normally in layman's term, these are counting numbers. That's how it's because that's how we count numbers, starting from 1, 2, 3, 4, 5. We count with our fingers. We have 5 fingers. That's how it is. Natural numbers or counting numbers. So these are called natural numbers. So let's just put it this way. And natural numbers or counting numbers, and see. And if you go down on the left of 1, that is 0. Let's say it here. So that's 0. Add this 0 right here, and now you're starting 0, 1, 2, 3, 4, 5, and these are called whole numbers. So from here to there is a whole number. So these are from here. So 1 to 5, and of course not just 5. It counts to up to hundreds, millions, or billions. That's what we call natural numbers. Once we add 0, that's what we call a whole number. That's our whole numbers now. That's whole numbers. So far we have all those numbers from 0 to the right. We have the positive numbers, 1, 2, 3, 4, 5, counting numbers or natural numbers. Once we add 0, what we call whole numbers now, from 0, 1 to 5, and so on and so forth. Non-stop to infinity. That's what it means by the arrow sign right there. And whole numbers, if you know there's 0, how did it come to be a whole number? 0 is considered a whole number, but neither a positive or a negative. So in mathematics, that's considered a whole number, 0. If we go down to the left of this number line, we will be seeing negative numbers, right? So say -1, -2, -3, -4, and so on. All right, that will be to the left on the arrow, going down to the left to infinity. So, and what do you call these numbers now? These negative numbers, if you take a look at the number line, the negative numbers, and now you have the 0, and then 1, 2, 3, 4, 5, and all that. So these are called integers. So that includes the 0, the positive numbers, and the negative numbers. So that's what we call from here to there. That's the whole thing now, from here to there. So all of that It's what we call integers. Okay, so these are all integers. You might be wondering, you may have a question in your mind, how about rational number and irrational numbers? So those are good questions. Rational numbers are numbers represented in fractions. So that means any of these numbers are rational numbers. Since rational numbers are any integers represented in fractions, in fractional form, from the word ratio. Like on the list earlier, 1/2, that's a rational number. So any of these integers right here expressed in fractions. So that means 4 or -4 is a rational number, since it can be represented as -4/1. So that's a rational number. Same thing on 4 or 5 or 3, or here 5 is also a rational number, and it is a natural number, a whole number, an integer. And as a rational number, 5 can be expressed as 5/1, is because that's simply 5. And 0 divided by 2, 0 divided by 1 is 0. Or any number divided by 1. So these are what we call rational numbers. And how about on the other side of real numbers, irrational numbers? What are they? So that's another good question right there. If you investigate or take a look at all these numbers, irrational number is not of any of these kinds. So not. That's why rational number is separated from all of these. So what does it mean by irrational numbers then, right? So you might be wondering, hey, what the heck is that irrational number? So since any of these is not part of irrational numbers, if we go back there on our list and investigate these numbers, we can find a couple of those irrational numbers. So in our list, if you notice, square root of 5, you did not see that on the number line. And how about this? Pi. How about this? 2.13113 and then 1113 right there. So these three are irrational numbers. How did we go to that naming these numbers as irrational numbers? So anything not classified under rational numbers are irrational numbers. So to better explain what irrational numbers are, the symbol pi here, that pi actually is represented by, is written in numerical value as 3.14, 15, 9, and so on. So that means this number, the decimal place is never ending. It goes to infinity. So there's no pattern, non-terminating and non-repeating decimal numbers. So that means this goes on forever. It goes forever. So they will be counting forever. So whenever we have that, there's no repeating number or terminating number on a decimal. That's what we call irrational number. And if you take a look at this number also, 2.131131113, so there's no pattern and this is non-terminating. So it is called irrational number, and this number actually never stops. So that goes to infinity the same way. Now if we go over to our list on all other numbers aside from the 3 right here, categorized under irrational numbers 1, 2, 3, we have this negative. Negative number is a whole number, at the same time in natural number, and at the same time an integer. Since integer is a signed number, you got plus or positive or negative numbers are signed numbers that include 0. So this is the same thing. Integer, negative. And 0 is classified under integer also. It's because and then 0 is classified under that neither a positive or negative number, and is considered a whole number as under integer, under whole number. And natural numbers include all the counting numbers. 5 is counting number. 1/2 over here is a rational number that's expressed in fraction. So that means a combination of two numbers, what we call integers, combination of integers, represented in fraction. 1/2. 1 is integer, 2 is an integer. And square root of 5, we had that already. That is irrational number. Why is it called irrational numbers? Because these numbers are numbers that cannot be expressed as a ratio. The square root of 5, since its square root of 5 is a non-terminating, it has a non-terminating decimal place. If you get the square root of 5, if you hit your calculator, it would be a whole long string of numbers after that. So 2 something. So 2 point, okay, on the decimal place, it will never end. So that is like 2 point something, say 2.236 and so on. It will never end. So that's why it's called irrational number. Cannot be expressed as a ratio. How about this one right here, 0.01, right? Well, that is a rational number again. Why did we call that as a rational number? Why is it classified as a rational number? It is because any decimal expression of numbers, that let's say this 0.01 is represented, can be represented as a ratio. Since 0.01 is represented as 1 over 100. If you take a look at the decimal place 0 and 1, you get these two decimal places to the right, to the left. That means it is considered as a ratio, is because you can express as 1 is over 100. How about the other one right here, right? 0.123 and the dots on those, what does it mean by that? Well, that's another question. So that's a good question, by the way. And that is, so that number, by the way, is 0.123. What are those points right there on top of those, over on top of 1 and 3? What does it mean by those? That indicates this decimal place is never ending, but it is a repeating number. So that means that is 0.123. So the point right here on the first one is the start of the repeating series, and this is the end of the repeating series. That means this repeats over and over, and it means 0.123, 123, 123, 123, 123, all of that. It will never end. But it's repeating. So that is considered as a rational number again. Why did we call it as a rational number, unlike those repeating numbers like this? Since this number right here is, there's no pattern, and it is not repeating decimal places. It's not repeating. It's non-repeating on a decimal, and here is repeating. So this is called a rational number, since we can represent this in fractional form. How are we going to represent this in fractional form? So that is equivalent to 123 divided by 999. So that can be expressed in fractions as this 123 divided by 999. The equivalent, if you use your calculator, it would show up a repeating number 123 on the decimal place. So it's actually 123. That's the same thing as that. So that is a rational number. So any integers, whole numbers, or natural numbers represented as a fraction, so those are all rational numbers. On the other way, on the other side of the coin of that real number is irrational numbers. So all numbers that cannot be represented as a ratio is irrational number. So that ends our lesson. And before you guys go, before I let you go, you have a little practice to do it right here. Identify these numbers according to the number system, the classification of real numbers. 1, 2, 3, 4, 5, 10. So you have 10 items for you guys to practice at home at your convenience. So you get more practice when it comes to number systems, classification of numbers, real numbers. Okay, so that's all for today, folks, and I hope you enjoyed this tutorial video on number systems, all about real numbers. And if you do like this video, just don't forget to hit the like button or subscribe to help me out so you get more videos in the future. Thank you very much and have a great day. Maraming salamat sa panonood, mga kabayan.